We want to prove the identity sin 5 theta plus sin 3 theta divided by cos 2 theta is identical to 8 sin theta cos squared theta. I'm going to attempt this by going from the left-hand side to the right-hand side. The left-hand side contains an expression where I can use the sum and product formulae, so it seems sensible to start with this side. So let's start with the left-hand side. Sin 5 theta plus sin 3 theta can be changed using the sum and product formulae. This will become 2 times the sine of 5 theta plus 3 theta divided by 2, which is 4 theta, times the cosine of 5 theta take away 3 theta divided by 2, which is just theta. All of this is divided by cos 2 theta. Sin 4 theta we can expand using the double angle formula. Sin 2a is identical to 2 sin a cos a. It follows that sin 4 theta can be written as 2 sin 2 theta cos 2 theta. The rest of the expression remains unchanged. We can see the cos 2 thetas will cancel, and this gives me 4 sin 2 theta times cos theta. Once again, sin 2 theta is 2 times sin theta times cos theta. This is using the double angle formula again. And so tidying, 4 2's are 8. We have a single sin theta, and cos theta times cos theta is cos squared theta. And we can see that this is the right-hand side.